Hello everyone. Today we are going to discuss about concept of free energy. First of all, we have to know that what is this energy means. Energy. What does this energy means? Energy is the ability or capability to do work in a system. And what is energy? It is the ability, or you may say capacity or capability of a system to do work. Okay, it is the ability or capacity of a system to doing any useful work. This energy is maybe two types. One is potential energy, another is kinetic energy. Potential energy is the energy which is associated in the system, and kinetic energy is the energy which is present or which is occupied or which is formed due to the movement or motion of the body or motion of the system. Okay, so this is the energy, and we are going to discuss about what is free energy. Okay, what is free energy? What does this free energy means? Free energy is the energy which is free to do some useful work. Okay, the energy which is free, that means never or neither associated with any other work. Okay, which is free to do work or do some useful work in a system is called the free energy. The energy which is free to do some work, neither associated with any other system nor functional in any other way. The energy which is free to do some work is called the free energy. Okay, it is the useful energy which done all works in a system. The energy which does all functions of a system is known as the free energy. Okay, then in biological system the free energy is the energy which is liberated or excreted or may be occupied in a chemical reaction. In biological system, the free energy is the energy which is liberated or utilized or given, liberated or utilized in a chemical reaction. We may say that in a chemical reaction, the energy which is liberated or excreted out or may be utilized or taking the energy to start the reaction called the free energy. Okay, then mathematically this free energy is Gibbs free energy. Gibbs free energy is denoted as G. This is mathematically G is equal to H minus Ts. Okay, Gibbs free energy G is equal to H minus Th, where G is Gibbs free energy, H is enthalpy, that means heat content of a system. Heat content of a system is called enthalpy. Then T refers to temperature and S refers to entropy or the waste energy. G is equal to H minus Ts. Then Helmholtz free energy, Helmholtz free energy. It is denoted as F. F is equal to U minus Ts, where U is internal energy, T is temperature, and S is the entropy or waste energy. Here U is internal energy. Okay. So this is the concept of free energy. Okay. The next thing comes, what is change in free energy? The next things come is change in free energy. Change in free energy is denoted as del G. Okay. What is change in free energy? What is change in free energy? The change in free energy is defined as the energy change, the ability or capability or capacity or amount of a free energy change, the amount of a free energy change or the portion of a free energy change which is capable to do work. Okay. The change in free energy. Okay. The amount, or you may say portion, T-O-R-T-A-N, amount or portion of a energy change which is available to do work in a system, to do work in a chemical reaction, you may say, in a or biochemical reaction, is called the change in free energy. Okay, the amount of free energy change or the portion of the free energy change which is available to do work, to do any useful work in a chemical reaction is called the change in free energy. Okay, this is denoted as del G. Suppose imagine a chemical reaction, a reactant R1 plus R2, a reversible reaction giving rise to product P. Okay. Suppose the free energy associated with reactant is denoted as Fr and the free energy associated with product is Fp. Okay. Then for forward reaction, forward reaction means R1 plus R2 giving rise to product. This is the forward reaction. For forward reaction, the value of del G, change in free energy, is product minus reactant. Remember this one. Okay. The value of del G is free energy, Fp. What is Fp? Free energy associated with product, and Fr is the free energy associated with reactant. So in forward reaction, del G or change in free energy is free energy associated with product minus free energy associated with reactant. That means this value is always a negative value. Okay. The del G or change in free energy associated with forward reaction is always a negative value. That means the forward reaction occurs with decrease in free energy. That's why the value of del G, change in free energy associated with forward reaction, is negative value. Okay. Then as the value is negative, that means free energy change is decreased. That's why always the forward reaction is assumed as exergonic reaction. That means the reaction where energy is released or liberated to the environment. Okay. This is the for forward reaction. For forward reaction, change in free energy value is always positive. Then for backward reaction, that means like this. For backward reaction, the del G, change in free energy value, is altered. That means reactant minus product. And for backward reaction, the value of del G is always positive. That means the backward reaction occurs with increase in free energy. with increase in free energy. That means this backward reaction is always a exergonic reaction. That means it required energy. Sorry, endergonic reaction. ENDER. Endergonic reaction. Endergonic reaction means it required energy to initiate the reaction. Okay. This is for backward reaction. This is asked in short question. Always this is very important for short question. The change del G, change in free energy value for forward reaction is negative. For backward reaction is positive. And when zero, when the system or when the chemical reaction attain the equilibrium, is at equilibrium. When the chemical reaction is at EQUILIBRIUM, at equilibrium, del G value, change in free energy value is 0. Okay. Del G, change in free energy value at equilibrium is 0. At forward reaction negative, backward reaction positive. Okay. This is the thing of change in free energy. Then another thing comes. Another thing comes is standard free energy change. Okay. Standard free energy change. Standard free energy change is denoted as like this, del G0. Okay. Standard free energy change. What is standard free energy change? The energy change. Okay. The energy change associated in a reaction which is free to do some work is called standard free energy. Okay. The free energy change, the free energy change the free energy change of a reaction under standard condition. The free energy change of a reaction under standard condition. Standard condition refers to 25 degrees Celsius and 1 atmospheric pressure. 25 degrees Celsius temperature and 1 atmospheric pressure is called the standard condition. The free energy change of a reaction under standard condition is called standard free energy change. Okay. Then what is the difference between change in free energy and standard free energy change? The major difference is that the value of change in free energy is a variable. That means it varies. It varies, not a constant value. The value of change in free energy is not constant. It varies. But the value of del G0, that means standard free energy change, is a constant value. And it does not vary. Okay. And this value, del G0 value, says that, determine that in which direction the reaction is flowing, in which direction, whether that is a forward reaction or that is a backward reaction, in which direction the value of standard free energy change says that in which direction, whether that is forward reaction or backward reaction, in which direction the reaction occurs, the reaction flows, and how far it will go to attain the equilibrium, and how far it will go to attain the equilibrium. Okay, so this is the standard free energy change. Standard free energy change is the free energy change of a reaction under standard condition. Free energy change of a reaction under standard condition. That means at a constant 25 degrees Celsius temperature and at 1 atmospheric pressure. This value is a constant value and this value is a variable value, free energy change. So this is the major difference. Okay. So this is the basic concept of free energy required for a biological student. Okay. So thank you everybody for watching. Thank you.